I'm sure that all of you are aware that the human brain is organized into a left and a right hemisphere. Each hemisphere of the brain is responsible for what happens on the opposite side of the body. So, for example, the left hemisphere is the part of the body that would control the right side. If you wanted to raise your right hand or tap your right foot, it's your left hemisphere that would be responsible for that. Or if you wanted to raise your left hand or tap your left foot, it would be the right hemisphere that was doing the work. Each side of the brain also receives sensory information from the opposite half of the body. So if somebody were to punch you in your right arm, it would be the left hemisphere of the brain that would register that event. If somebody were to pinch you on your left arm, on the other hand, it would be the right hemisphere that registered that information. The two hemispheres of the brain share information with each other through a structure known as the corpus callosum. It's a bundle of nerves that connects the right and left hemispheres, and it's the only channel by which information from one side of the brain can make it to the other side of the brain. We're going to talk about the organization of the hemispheres of the brain as if we're talking about a right-handed person. If you're right-handed, we know exactly where everything is located in the two hemispheres of the brain and what functions reside there. If you're somebody who isn't strictly right-handed, however, it's less certain. For about 60% of non-right-handed people, the brain organization is highly similar to that of right-handed people. But for the other 40%, it's all over the place. You never know for sure where things are going to be located. And these people have to undergo significant testing before they go into brain surgery to figure out where all of the different functions reside. It's really a misnomer to refer to somebody as being left-handed. There's right-handed and other. Most people who are not right-handed are more along the lines of what we would call hand-specific. It's not as if they do everything left-handed, the same way most right-handed people do everything right-handed. There are people who fit that description, but it's more common for non-right-handed people to do some things with their left hand and some things with their right hand. Anyway, we're going to talk about the organization of the brain as if we're talking about a right-handed person, but just keep in mind that this may not apply to absolutely anyone. On a quiz, if I were to ask you where things are located in the brain, I will always be making the assumption that we're talking about a right-handed person, unless the question explicitly states otherwise. Having said all this, for right-handed people, the left side of the brain is responsible for what we think of as the sort of logical functions, your ability to do language problems, to speak, to understand speech, to work with math. The right side of the brain is responsible for more spatial kinds of things, processing color, processing emotion, recognizing faces. Here's a diagram that kind of breaks things down a little more specifically. So if you want to think of this in terms of the Knox College campus, the left side of the brain would correspond to the things that go on in SMAC, but also things that have to do with languages. The right hemisphere of the brain, on the other hand, would be more the arts. Here's yet another diagram that depicts the breakdown of functions in the two hemispheres. And I kind of don't like this, being a science math person, because it makes one side of the brain look a lot more fun and interesting than the other, and that simply is not true. Now, how do we know which things are located where? For a long time, we had to rely on natural accidents to figure out where things happen. So, for example, you would examine the brain of somebody who had particular talents or skills after they died and try to figure out if the brain looked any different than somebody else's. This was not a very satisfying way to go. Fortunately, we now have a wide range of technologies that allow us to study a living brain as it's performing different functions. MRIs, magnetic resonance imagery, and PET scans are two of the most common ways of doing this. In each case, you can take a look at a brain while it's functioning and see which part of the brain is doing what. Here are some pictures of brains involved in different types of operations. For example, if you look at the one in the center at the top, a person listening to music, you'll notice that the right side of the brain is very active. Active areas are represented in red. On the other hand, the one in the upper right-hand corner reflects a person engaged in some sort of cognitive, academic sort of task. And you'll notice that it's the frontal lobe of the brain that is very well lit up. The one in the dead center shows a person engaged in a language task, and you'll see that it's primarily the left hemisphere of the brain that's active. And in the center left, a person engaged in a visual task shows a lot of activity in the occipital lobe of the brain. So using these technologies has really helped us figure out where things are located. On the quiz for this module, I'm certain to be asking you a lot of questions about what kinds of things happen in which part of the brain. So that's something you're going to want to work on when you're studying. Another dramatic way in which we've learned some fascinating things about how the hemispheres of the brain are organized comes from studying individuals who are known as split brain patients. Split brain surgery was something that was done back in the 1950s and 60s as a last resort effort to treat epilepsy. Epileptic seizures that race through the brain can be very traumatic for the individual having the seizure. And severing the corpus callosum was a way of confining the seizure to one half of the brain and dramatically decreasing the intensity of the seizure. Split brain surgery went out of fashion for a while because there was the development of drugs that seemed to be promising as a way of treating epilepsy, and they were certainly less invasive and less dangerous than doing brain surgery. So for quite some time, split brain surgery was something that was pretty rare. It's making something of a comeback now for a variety of reasons. It turns out that the drugs are not equally effective for all people, and some individuals experience some unpleasant side effects from the drugs. And plus, our techniques for surgery have gotten so much better that the operation is not nearly as risky as it once was. So we're now starting to see some more split brain patients again. But anyway, given that split brain patients existed, they were a treasure trove of information for brain researchers because now we had individuals whose two hemispheres of the brain were completely separated and could not communicate directly with each other. Now, in day-to-day life, these individuals function pretty well and don't seem to be different from anybody else. But if you bring them into the laboratory and give them very specific tasks, we find some fascinating effects. It's almost as if we have two different people residing in the same head, two different brains, and they each know different things, and they can compete with each other when they're trying to do different things. It's hard to describe this in words. There are several clips on this module to see split brain patients. One of them is for a guy named Joe, and that clip can be found on the page. But there's another one for a woman named Vicky that you can see at the end of this PowerPoint slide. Just by clicking on her name on the PowerPoint slide, you should be able to get to the clip. So let me describe the type of experiment you would do to see the divided consciousness of a split brain person. This diagram shows how the visual pathways work. I won't get too bogged down in the details here, but basically if a person is fixing their stare at a point right in front of them and they're not moving their head around, information from the right side of the world hits the left side of the eye and gets transmitted to the left hemisphere of the brain. So the left hemisphere is seeing the stuff on the right side of the person's world. The right side of the brain is seeing stuff on the left side of the person's world. So this means the two hemispheres are seeing different things. And so, if you present the individual with the picture of an orange on the right side and ask the person what they see, they'll say, I see an orange, because the left hemisphere of the brain saw the orange and the left hemisphere of the brain can talk. If, however, you projected a picture of an apple to the right side of the brain, the right hemisphere, if you asked the person what they saw, they said, well, I didn't see anything. The right side of the brain saw the apple, but the right side of the brain can't speak. It's the left side of the brain where speech abilities are located. However, if you ask the person to reach for the thing that he or she saw with their left hand, they can pick out the right thing, because the left hand is controlled by the right hemisphere, and the right hemisphere knows what it saw. So this is kind of creepy. You've got a person saying they didn't see anything, but clearly they did. Similarly, let's suppose you put a person in a situation where they're staring at that focal point in the center, and the word ring is being projected to the left hemisphere, and the word key is being projected to the right hemisphere. If you ask the person, when the two words flash on the screen, to tell you what they saw, they'll always say the word ring, because that's what the left hemisphere saw, and the left hemisphere is the one that can talk. However, if you were to ask the person to, with their left hand, feel the objects on the other side of the screen and pick up the one that they saw, they'll pick up the key, because it's the right hemisphere that's controlling the left hand, and it's the right hemisphere that saw the word key. And so you've got these two halves of the brain that don't seem to be talking to each other, and it's almost as if there's two different people in there. Some of the split brain patients, shortly after surgery, talk about the problems they have when they go to pick out clothes from their closet, for example. The two hands will grab two different things and maybe even fight with each other over which thing that they're going to wear that day. So here are links to video clips for two split brain patients, Joe and Vicky. There's another link to this clip of Joe on the webpage for this module, but they will show you more graphically than I could say in words exactly how these people behave when you put them in experiments to see what the effects of split brain surgery is.